came home from school today and your teacher gave you a lot of high degree polynomials to factorize as your homework. But I guess this is going to be your reaction. Why? Because the only method you know is your old conventional Stone Age long division method to check for factors. But don't worry, I got you. I have something for you which is a lot efficient than your Stone Age method, I guess. So let's start. Let us say we have a polynomial p of x which is supposed to be factorized by long division method. Now in order to do this, we take a random linear polynomial and divide p of x by this. Here we took x minus 1 as the divisor. Upon division, we see x minus 1 is a factor of p of x. So p of x can be written as the multiple of factors we just got. Now we do this guess and long division work until we write the entire polynomial p of x as product of its factors. In this case, we can see that x square plus 3x plus 2 can still be written as a product of two linear factors. So we do the guesswork again and choose x plus 1 as the divisor and then do the long division process to check whether it's a factor or not. Well, this time we were lucky and all our guesses were right. Now, as we can see, this method of factorizing is too tedious even with lower degree polynomials. And remember, if we guess the wrong factor, the entire long division gets wasted. So in order to simplify this, we have something called Remainder Theorem or Factor Theorem, which helps us to find factors without even dividing it by any such random linear polynomial. Let us say we are dividing 17 by 2 using the normal division method. In order to find the remainder and check whether 17 is a multiple or not, we take the closest multiple of 2 to 17 and then subtract it from 17. Now the obtained remainder. So we can say that 17 is equal to the closest multiple of 2 to 17 plus the number we came short of, which is nothing but a remainder. So we can say any number can be written in this particular format. The number itself is divisor times quotient plus remainder. So to summarize, what we did here is that we subtracted the closest multiple of the divisor from the dividend to obtain the remainder. Now if the remainder obtained is 0, then the divisor is the factor of the dividend. But here, we need to find the quotient each and every time in order to figure out the closest multiple, which generally consumes a lot of time. So instead, we use something called as the factor or remainder theorem. Let's bring the previous polynomial p of x, which we factorized earlier using long division. Now let's check whether x minus 1 is a factor or not using this theorem. We can write p of x as the divisor times the quotient plus remainder. Now, can you find out a way by which we can eliminate q of x? Remember, p of x is a polynomial, so we can enter any value of x now. Pause for a second and try it yourself. Okay, now let me answer it. Now if we substitute x as 1 here, we can nullify the entire q of x, the term which was creating a problem since the beginning. Now we are only left with r. Okay, now let me walk you all through the definitions real quick. Now the remainder theorem states that if p of x is a polynomial which is to be divided by x minus of a, then the remainder obtained will be equal to p of a. Now the factor theorem states that if p of x is a polynomial and x minus of a is a factor of it, then p of a is equal to 0. Hey, before leaving, let me tell you something. If you somehow stumbled onto this channel for the first time, so did I. This is my first video after all. If you have any questions, drop them in the comments. I will do my best to answer. And if this video helped you even a little, consider leaving a like. Until next time, stay curious.